rather than a few weeks down the road, because we've just talked about pen testing. We even mentioned ARP poisoning briefly. But while it was still fresh on your minds, I figured it would be a good time to go ahead and go into more detail about it. So obviously the first question is what is ARP poisoning, or perhaps even better yet, what is ARP? ARP is the address resolution protocol.
Is that like kind of the same thing as DNS? Or?
So DNS works on IP addresses, so it works on the internet level. ARP is specifically on the LAN level.
Yeah,
what ARP
it's very similar.
Is it well, except DNS is hierarchical, whereas
ARP is entirely flat. Each adapter is assigned what should be a completely unique ID. I could go pull it up the specs for it if I really wanted to, but it's probably not worth the effort. But basically the first few bytes of that number, if you were to go pull up your MAC address, identifies the vendor, and then the rest of it is unique. So in theory, every single device in the world should have an individual MAC address, and that allows it to identify itself on the network. Well, obviously, if you're using the IP protocol, that works on IP addresses. So you have to have a way to bind the two together. So ARP basically binds the IP address to the MAC address. So ARP poisoning, also known as ARP spoofing, is the exploitation of this low-level networking protocol I was just talking about. And we'll talk about exactly what the protocol looks like in a few minutes. Anyway, using ARP poisoning, an attacker is able to redirect a given IP address to his computer, or even to anyone's computer actually, but usually it'll be to their computer, or even redirect an entire set of IPs all the way up to every single computer on the network. This can be used as part of a complex attack like session hijacking. We briefly talked about that. Man-in-the-middle attack, or just a regular old denial-of-service attack. So here's a nifty little idea I had. I took the OSI networking stack, which doesn't perfectly translate over to what we're actually using, but is an easy heuristic to give you an idea of where a protocol is with relation to the networking stack. So ARP basically falls within the link layer. Now you can make arguments for it being in the network layer because it partially because it's part of tying the IP address from place to place. But if you go do some research, most people say, well, it falls in the link layer because it depends entirely on link layer resources. But basically what it's really doing is bridging the link layer and the network layer.
But what you're saying is that sometimes the network layer will access the link layer for its purposes of making the link layer more secure.
Well, it's not more secure.
Well,
ARP is extremely insecure. That's part of why we're talking about this.
Well,
there is zero security on ARP, in fact.
right.
So it's not there for security, it's for basic infrastructure. The network layer cannot exist without the link layer. The link layer says, okay, this IP address, in this case it says this IP address is associated with this MAC address.
Well, okay, so for instance, let's consider Cisco's NAC tool that they use. It uses the network layer, obviously, so therefore you're already connected to the local area network. You're just not being allowed to use the internet unless you have permission from this Cisco NAC agent. So,
although you have the basics of that idea right, technically you're wrong. Technically the only thing you're blocked for appears to be the web. So that would be SSL, I can't remember that protocol.
Well, it even permits you to go onto Google.
So I can get certain things like email that I'm downloading through an email client, not through webmail, obviously.
Okay.
And lots of other things that go through non-standard ports. Now, the interesting thing is, you do have to register before you can get anything, I think.
But,
I haven't actually done it.
But regardless, you didn't let me finish the story here.
Well, no, it's because I'm
well, anyways, my idea is, okay, what if you had something like that, where basically you were forced into a virtual network. Your computer was forced into a virtual network under the conditions, through the link layer, was forced onto a virtual network under the conditions that you did not connect properly through this particular Cisco NAC agent. But once you did, it utilizes the link layer to put you on a new virtual network that is appropriate. So you can basically have the network layer utilize the link layer in order to put the user in the correct position on the network.
That might go higher than the network layer.
Oh yeah, well, I mean,
That's-
certainly it
that's-
goes much higher.
I mean,
It goes all the way up to user application. I
could
mean, because the
certainly-
NAC is a user
You
application.
could
so-
certainly write something like that.
Yeah.
I'm not sure anyone would bother. Because you can do just as much restrictions on the network level as you can at the link layer, as far as the type of stuff we're talking about. On the other hand, that might, well, no, I guess it wouldn't
I think it
because
would
of what
be
we're
more
about to
nifty.
talk about.
Yeah.
But why don't you bring something like that up after we've talked more about ARP, so everybody else can keep pace?
Okay.
So I guess I've basically already described part of this. ARP is what establishes your link between a MAC and an IP address on a LAN. What ARP mostly is, what you mostly will see if you go pull up, say, Wireshark and watch the ARP request, is basically it's a request response protocol. So the sender of a packet of data, so somebody looking to send something out over the IP protocol says, hey, who has this IP? The recipient, well, the intended recipient, is supposed to respond back, hi, I own that IP that was being looked for, and my MAC address is, 0123456789. All of the machines that hear this, so this includes any switches, update their ARP tables to reflect it. Now, the reason why I mentioned switches specifically is because a switch tries to optimize the network a bit. So you've got hubs and you've got a switch. A hub broadcasts every packet it receives onto all its ports. So every computer connected to that hub can hear every message that goes across it. A switch, on the other hand, tries to optimize it, tries to learn who is connected to what port, and then he only sends information over the port that he knows belongs to the correct computer. Now, obviously, when you change a computer, what port it's on, it can take a little while to update, but honestly, it's really well optimized at this point.
All right, so
just to let me interject there. So where would the hub or switch lie in the
where would
journey?
the what?
You said the hub, right?
I don't think
Hub or switch?
Yeah, the hub or switch. Where would those devices lie in the journey from a client A trying to request a page from the server B?
Well, so
Let's say
if
those aren't going to be on either the client or the server. They're going to be in somewhere.
I
in
was
between.
getting there.
Oh, go ahead.
Generally, and this is a potentially a gross stereotype of a regular network, but generally what you would have is you have a set of computers and they're all hiding behind a gateway or a router, but you can have a router that's not a gateway, which is why I call it a gateway.
Okay.
So that gateway is what lets everything talk to the bigger internet.
I see.
So those switches or those computers cannot all be on the same line as a router, right? Technically they could according to the Ethernet protocol, but we don't do it that way, so never mind. So those computers all need to be able to hook into that router somehow. So this router technically only has two ports, one that goes to the outside internet, one that goes onto the inside network. Okay, most routers have a handful of switches, but let's ignore that case.
Okay.
So obviously if we've got 5 computers and we need to connect them to one port, we need something to let us do that, right? So we can get a hub, which as I said, could let us broadcast everything to every computer on there, or we get a switch. And that is what sits there in between the two things and connects. Now this is just a really simple network I just described, not a really complex one.
But okay, so the hub broadcasts all the information it receives to all the ports listening to it. Doesn't that mean that all these computers are going to get, most of them are going to be getting data
That they don't need.
right?
Yeah,
So how
a hub. That's why we have switches. They're meant to optimize and replace hubs.
So are hubs have they gone obsolete at this point, or
Pretty much.
Okay.
If you've got a hub, there might be a few things you could do with ARP poisoning, but honestly, ARP poisoning mostly applies to switches.
I see.
At any rate, so continuing, I'll ask for more questions if there are more in a minute, but I wasn't quite finished with ARP. So I mentioned that normally ARP is a request response protocol. Unfortunately, it also supports a gratuitous broadcast. This allows a machine to announce ownership of an IP. So basically, this is when some loud, irritating machine shouts out, hey, I'm MAC address 0123456789, and I own this IP, rather than waiting for someone to ask who owns that IP. So obviously, the reason why I use the word unfortunately is because that allows us to do nasty things. Now, an interesting side note is that you might question, why would anyone have made their protocol like this? There's no authentication. There's no way of verifying that this MAC address actually belongs to this IP address, right? And the answer is because this was developed in, I think it was 1973. And at that point, so few people could afford to pay $5,000 for an Ethernet card that they really didn't care about security, because who was going to be able to afford to break into their network this way anyway? Fast forward into the 90s when everybody's using Ethernet, and suddenly it becomes an issue. Were there any questions here?
So the MAC address lies on an Ethernet card. Is that right? Is that what you said?
Yes, the MAC address is associated with an Ethernet card.
Okay.
Yeah. I mean,
you can change it to the computer, yes, but it is not associated with the computer. You buy you buy two network cards, and oh, by the way, wireless networks use Ethernet as well. Even though you don't see the cables, they're using the same protocol. In case anyone was wondering. So they also have MAC addresses. What?
Ethernet's a protocol?
Technically, yeah. It's also, I think, a brand name. Well, maybe not. But we say Ethernet cables, but now it's been expanded to include non-wired communications. Okay. So yeah, it's a protocol.
I mean, I just, I can see how this could be said, but to me, any network that's properly secured is not going to allow that sort of thing to happen. A machine can't just simply say, hey, I'm this MAC address and I am this IP
What's
address.
interesting is we're going to get on to defenses. And if you bring that up there, I'll tell you why you're probably wrong. Except in very rare cases. There aren't very many networks you can really do that on. So any other questions about the ARP protocol?
All right, so we'll talk a little bit about how we actually do ARP poisoning now. So ARP poisoning, it relies upon the ability to use the gratuitous broadcasts that I mentioned. So I told you it was unfortunate, and I wasn't kidding. So first off, here's a little example of an ARP cache. So this is where a computer or switch stores what IP addresses are associated with what IP addresses. And this is just a really simplified version. I think there's also a timeout field, and there might be a couple other things associated with it as well. And of course, the short name is not actually included. So you'll notice I included an attacker, and although he has a MAC address, there is no IP address yet associated. So what can the attacker do? Well, this attacker wants to replace the recipient, right? So they send, hey, I'm MAC address 4567890123, and I own 192.168.0.2. So as you can see, that's what the recipient, that's what they own, their IP address. So once they hear this, all the ARP caches on machines that have heard this broadcast, they now change that IP address to point at the attacker's MAC. So as a result of this gratuitous broadcast we mentioned, the attacker is now receiving all traffic that was sent to that IP address. So they now get everything that was meant to go to that recipient. So you can see, I show the now poisoned cache, and you can see that the recipient no longer has an IP address. Well, it thinks it does, but everybody between it and who it wants to talk to doesn't have its IP address or correct MAC address anymore. So basically it doesn't. So now it's not receiving those messages. So one of the caveats is an attacker has to refresh the ARP caches with a broadcast on a regular basis, because periodically this request response thing just occurs to make sure that there's nothing out of date. So I mentioned that if you were to change a port, then you have to be able to update it. So this happens a lot. But I mean, if you could refresh it, say, every 30 seconds, assuming that the timeout for an ARP cache was 35 seconds, it's not a problem, right? Anyway, most defenses have no defense at all against ARP poisoning. So are there questions? See? Good timing.
IP addresses are unique. What happens when your MAC address already exists in the table? How is that resolved, or are you just denied?
When you say it already exists in the table, do you mean a duplicate MAC address?
Correct.
Well, that can happen. You can force that to happen. In theory, that doesn't happen, like I said, because they're supposed to all be unique. I can reset a MAC address. Now, that's an interesting question. The answer may be that both targets get the traffic from that. I'd have to experiment with it or do some reading to be sure. But the answer may very well be that just both recipients get it and it just has dual entries. I'm not totally sure. Because you could conceivably have a reason why you'd have two diverging network routes that meet back up on the same machine at the middle for whatever reason. I'm guessing that's really going to depend on the specifics of a router implementation. There may actually be nothing in the protocol addressing that. Are there any other questions? So now we'll talk a little bit about where we can use ARP poisoning. This is not necessarily the first thing I jump to. In fact, I'm not sure why I put this in this order, but anyway. So ARP poisoning with session hijacking. Well, we talked about session hijacking last week, and this is the process of replacing one of the parties in an established channel with the attacker, one or both. So this can include a session that's been authenticated, but doesn't actually protect the integrity on the channel. So this would be like Telnet. Telnet is basically what SSH replaced. It authenticates with a password and username and password, which actually sends in the clear, so you could just flat out get the password if you caught it early enough. And at that point, anything that is sent over that Telnet channel can be changed, and the recipient won't notice. So anyway, ARP poisoning allows session hijacking to happen because the attacker is able to just flat out replace one of those two parties. It changes the MAC address associated with the IP address, so it starts receiving all the traffic. And of course, it can send traffic like that, but you could spoof that anyway. Anyway, unless an attacker knows the proper responses to the messages that are sent, obviously the channel is probably going to break. So the first diagram here is just your basic, you've got a nice little authenticated session between these two machines, and you've got an attacker sitting back there, and he really wants to get into this channel. So then the attacker performs the ARP poisoning. Now, I only show it as poisoning just the client, but technically this broadcast goes out to every computer. I just wanted to keep this chart or this diagram as simple as possible. So you can see the attacker has sent to the client, and he says, hey, I'm 192.168.0.2, which is in reality what the server is supposed to have as its IP address. So now that he's done that, the client has updated its ARP cache, and now it's talking to the attacker on this still authenticated session. It can't tell that it's not talking to the correct computer anymore. So you can see where this might be a bit of a problem. So any questions about session hijacking through ARP?
So basically, when you connect to the internet, you're at the mercy of the switch on the router. Is that right?
Yes. Now, I'm a little bit concerned about the way you phrase this because this only works over the LAN. So when I connect to the internet, I can't attack it. Now, if I could hijack a session that's going through a router and take it over, then I could talk to the server pretending to be the client because I was able to steal his IP address. Or I could hijack the session in the other direction. So I hijack the router's IP address, and I intercept that traffic, and I pretend to be the server talking to the client. But this would not work if I was not on a LAN with either the server or the client.
I see. Oh wait, a LAN, local area.
Local area network,
Yeah.
yes.
Okay.
So that's, like I said, everything behind that gateway.
All right. I see.
Okay, that's pretty much what I've been waiting for too. That explanation. If somebody's on the internet, it's extremely hard to do this if they're communicating over a router.
You could use other approaches.
Yeah.
But you couldn't use this approach.
Yeah, this approach.
If I was outside both LANs, like I said, if I was within either of those LANs, then I could do it.
Oh, if you were outside both.
That's right. Otherwise, if I'm still inside the LANs, I can still intercept that traffic because it's going through the LAN. And as soon as I'm on the same LAN, I can use this.
Maybe if you had two different people at both LAN locations.
No. If I was on either one of the LANs, I could do this.
You'd have to intercept traffic.
Let's say
from a router.
Let's say
but
let's say I'm on the client side, right?
Right.
So I'm on the same LAN as they are. This client has a connection to a server that's over the internet.
Right.
So I can do ARP poisoning, and I tell the client that I'm that router, I'm that gateway. So I'm getting all the traffic passed between the client and the server. So I can pretend to be that server to that client, and I can pretend to be that client to the server.
You won't be able to pretend to be the client to the server unless you had somebody at the server location.
No, because I'm sitting on this network. I can stop all the traffic that client sends and impersonate that client because I've just hijacked that session. Because that session passed over the LAN, and once it's on the LAN, I own it.
So what you're saying is you would go back and you would pretend also to be the client as well.
Yeah.
So not only are you going to have somebody.
No, you don't have to.
You would need two computers on that network.
No, you can do it with one. Computers are plenty fast enough to handle two sessions at once.
Okay.
And if I'm acting as the router, then I've taken over the router IP address.
Well, now
right?
you have to go
100%.
tell that router that you're the client.
Yeah. So that
but
router
you've already told the client
to
you're the router. So won't the router and the client get?
So why don't you hold on a minute? Hold that question for a few minutes. We're about to hit man in the middle next.
Okay.
Man in the middle may answer your questions. If it doesn't, then you should ask them then. You had a question?
Does ARP exist on ring networks where you have 2 NICs per PC and each is connected to the next, to the next, to the next? And
Wow,
if so,
I like that question.
if so, does each computer keep a cache, or
Hold on a
surely
second.
they don't?
Okay, so does it connect between? Wow, that's an interesting question. I like that. So,
Yeah.
possibly you could do a similar attack, but no, I don't see why ARP would exist in a ring network. And the reason why I say that is because in a ring network, I don't need a MAC address. I could just use an IP address. Does that make sense? I can draw a diagram if you like.
No. I just wondered if ARP had any place in that.
I mean, it's possible they use it, but I seriously doubt it. There's just.
What's a ring network?
I knew somebody was going to ask. Marker. If I'm not mistaken, this is effectively a ring network. Do you agree? I don't remember your name, sorry. Austin. That's basically a ring network, right? These are the nodes. These nodes are the clients. So they're all connected, and they're each connected at 2 times. They're connected to the computer on their left, and they're connected to the computer on their right. Okay?
Okay.
So they have a token that they pass between them. And this token indicates who is allowed to send the message. So if you've got this token, you're allowed to send data. So you then have a packet, possibly several packets, I don't remember all the details of the ring network, and you say, okay, I'm going to send this IP address to, you're probably not even using IP. I don't know if anyone ever adapted IP to ring networks. Anyway, you've got some form of identifier, and you say, okay, I'm passing it to such and such computer, and then each computer checks to see if that's the right thing. Now, this isn't actually all that different from a switch network in a lot of respects, if you're on a hub at any rate, because at a hub, everybody sees the message and they check to see if it's them, but they don't have to pass it on.
They do in the ring network.
In the ring network, they do. In the switch network, they don't. In the switch network,
Because
that's
the correct person should already be done.
ring networks really aren't very efficient.
Okay.
So I've never seen one used modern.
ARP poisoning for man-in-the-middle attacks. Well, you know, like I said, session hijacking, if all I've done is turn somebody off, is take somebody offline, I may not be able to respond correctly to whoever I'm talking to. In this case, what I'm going to want to do is I'm going to want to make a man-in-the-middle attack. That's where I sit between the 2 computers that are trying to talk to each other, and I can relay the data and certainly read it, possibly go ahead and tamper with it as it goes across the wire. So this requires the attacker to seize both the IPs of both the sender and the receiver. Once ARP poisoning is done to both of them, the attacker then routes the traffic it receives to the correct destinations. Obviously, like I said, this lets you sniff the traffic between the 2 targets, and it allows the attacker to modify the data between the 2 if they've got the tools for it, which are not as common as you'd expect. So I've got a nice pretty diagram again here. So the first stage is pretty much the same thing. There's an attacker eyeing that channel and wanting to get into it. Then the attacker sends an ARP broadcast, and like I said here, I've simplified this network design because there's going to be switches and whatnot between them, so this broadcast could go all over the place. But you know, he tells the server, hey, I'm 192.168.0.3, which is actually the client's address, and he tells the client the same thing, but he's replacing the server instead. So what happens after that phase where he lies to the client and server is there are basically two channels now, although the 2 victims think that it's the same channel, and they're both going through the attacker. So the attacker now has them convinced that he's really the other one. So he's able to read all the data, see it, do whatever pretty much. Yeah, so now I have to find where I was again.
Are there any questions on man-in-the-middle?
It seems like the most efficient way to do this would be to have 2 network cards. But you're saying you don't need to have 2
No, you don't really require 2 network cards.
Really?
Because those packets are not flying by that fast usually. There's enough bandwidth in most connections to where I could be just doing it with a single card. It's really not a big deal.
But wouldn't either the client see the attacker broadcast saying that it's the client.
The ARP protocol does not. ARP does not support that. ARP
Okay.
does not support that. So there is no way in ARP for me to come and examine, do sanity checks on ARP broadcasts. Nobody thought to do it. 1973. Who was going to be doing this? And we still haven't replaced it.
Well, okay, I can understand not having a sanity check necessarily for ARP set up at this point in time in regards to messages transmitted out, but for the client not to have a sanity check.
1973.
Or even for
who was going to be lied to?
This is not okay. These packets are not being transmitted out. We're not breaking any protocol. We're going to stick with the same protocol. The computer is going to see a message coming in, and it's going to read that message, and it's going to see that the message says, "Oh, by the way, this I am myself, or I am whoever is reading the message."
Yeah, you know who to go
and then it's
complain
going
to
to
about
say,
that?
"Hey."
You know who to go complain to about that? Microsoft.
Why?
Because they set the standard in the end, because they own 90-some% of the desktop market, which is the majority of all computers in the world, which is way too expensive as a result to go back and upgrade unless enough people put pressure on them that they do.
Since ARP is a link layer protocol, it seems like that would be an easy addition on the actual network card.
It's not done on the network card. It's done on the operating system. That's part of the network stack.
It just seems like the network card, whatever that is, the network card hardware could actually do that. Could do that simple sanity
It could, but it doesn't. As far as I know, nobody's doing it. Because the IP address is associated with the operating system. That's probably why. The IP address is associated with the computer, not with the network card.
Okay, so let's say the network card reads an ARP request, or an ARP broadcast, and the ARP broadcast says, "I am you," okay? Then why wouldn't it say, okay, well, which MAC address did this just come from?
Because it
Because
doesn't
whatever
say
MAC
IMU,
address this just came from, I don't trust
the
it.
Ethernet doesn't know what IP address it's associated with. The Ethernet card, that networking card, doesn't know what IP address it's associated with. That's the operating system's job. The Ethernet card just sits there, reads the protocol, puts it into a standard format for the operating system to read, and it passes it on to the network stack in the operating system. So it would be ripping out a lot of code to do that, ripping out some hardware, and it's not going to happen. Because there are systems still on the internet that are like 30, 40 years old. Well, 30 years old.
Well, that particular addition to a network card would not disrupt any kind of protocol on the
Nobody
network.
wants to do that, and it might just. You never know. Somebody may be depending on ARP broadcasts, and they may be using it in a strange way.
That would be a really weird.
What if I was on DHCP and my computer did not realize that its lease was up yet, and that DHCP server gave the same IP address to a new computer.
Same IP address to
Same IP address to Macs, and the one that owns the Mac now is the new one. So if I rejected that, then trouble in paradise, right?
You rejected it because it's your IP address.
But
So
it's
now
not anymore. I don't own that IP address anymore. It's been assigned to
Now
somebody else.
you cannot communicate with that PC. So communicate with the router and let the router deal with it.
ARP Poisoning Defenses. So there's really not very many of these. The first one that I've already mentioned is manually mapping ports on switches to a particular MAC IP pair. Unfortunately, hard coding this means that the network configuration has to be static. Laptops become effectively impossible to use because, well, assuming you want to connect to that network, because as soon as you change to a new port, you can no longer get an IP address. It'll no longer let you connect because you have the wrong MAC address for that point. And it's really nasty if you're using wireless, because what's the point in using wireless and hardwiring the ports anyway? I mean, you can do MAC filtering, but because of the fact you can spoof a MAC address anyway, who cares? So protecting the data at a higher level of the networking stack. So this would be if you were to go back higher up on like the networking layer or the application layer, or wherever on the networking stack, and use strong authentication, maintain a secure channel that defends against hijacking. That's the way to do that. And also if you provide, and that to protect against sniffing through like man-in-the-middle attacks, you would have to provide a confidential secure channel, so that would just be encrypting it for confidentiality. Technically, these don't actually prevent ARP poisoning, they just mitigate all the effects, so you don't care very much. And then finally, you can use an intrusion detection system to monitor for ARP poisoning for the signs. Questions? All right, so ARP poisoning lets an attacker steal an IP address from other machines. It can also allow, as a result, it can allow session hijacking and man-in-the-middle attacks to take place. Preventing it's pretty much impossible, and the only real good way to defend against it is to use good encryption schemes and authentication schemes. So references my typical counter hack reloaded. I've got a description of ARP, I've got the actual definition of ARP, that actual RFC, and I've got a description of ARP poisoning.